Finding the perfect dinghy for our classic schooner is not an easy task. We've done a lot of research on the internet for finished boats, kits, or even just plans for a dinghy that meets all our demands. But our search was unsuccessful. In the thousands of designs that are available, not one of them was the right one for us. So I've taken the liberty to design our new dinghy myself. My name is Gijs and this is my dad. And this is Schoener Tijgerhaai. We have recently started a major rebuild to get her ready for new adventures. And we're sharing the process with you. Subscribe to stay tuned. It's been a while since my last video, and that's because we were a little bit optimistic on how long it would take to build a complete dinghy. We thought about 2 weeks. That turned into 5. So let's dive into it straight away. I've been playing around with some concepts for dinghies for the past few months before settling on a final design that is easy to build and has all the properties of the perfect dinghy for our ship. For the design of the boat, I've used an open source software called Blender, which is a very versatile 2D and 3D program that I also use to make the designs and animations for my videos. To my knowledge, it has never been used to build a boat, but I like working with it and decided to see how far I could get before I hit the wall. That wall never showed up, and I ended up getting from nothing to fully finished building plans. I do want to walk you through the design process of the boat, but since this channel is more about boat building than it is about how to use a computer program, I will try to keep it in under 1 minute and go straight into building the boat. Keep in mind that I'm not a professional boat designer, but I have been doing it for fun since a very young age. The first step in designing any boat is a top view and a side view. Blender has a very useful feature called Bezier curve, which allows you to play around with the smooth shape of the boat without being constrained to using circles or ovals in your design. The next step would normally be a lines plan, but since this will be a multi-chine hull, to make it easy to build, we can skip this step and go straight away into the cross sections of the hull. I changed the resolution of the Bezier curve to 4 for the 3 chines or 4 planks to compromise between a nice hull shape and easy building. Next step is putting them all up straight and including a similar section for the bow. We can now create a surf curve that cuts through all these points. In order to get the 3D design of the boat into a printable building plan, we have to make use of the program in a way that isn't really intended. Because the hull planks are bent, we have to make them flat to be able to cut them out in the correct shape. Blender can do this with the function UV unwrap, which is normally used for editing textures on 3D animations. I select the plank that I want printed and choose one of the unwrap options. Smart UV project works most of the time. When you have all the planks, you can export them as an SVG or a PNG file. Right, it took me a couple of weeks to figure all that out, but now I have finished building plans for a new dinghy. If you want a more detailed explanation, please let me know in the comments. A subscriber named Leo Young suggested we build our new dinghy from aluminium. And after thinking about it for a while, we decided that's actually not a bad idea. Don't get me wrong, I'm a big fan of wooden boats and of the craft of wooden boat building. But we are actually not wooden boat builders ourselves, and since this is only a little sidestep in the big project, we don't want to spend too much time on it. In the end, it all comes down to the pros and cons of aluminium versus wood. So here's the list. Aluminium is more sturdy and requires less maintenance than wood and epoxy. We can build an aluminium boat faster than a wooden boat. We can have all the design parts laser cut out, and then we only have to assemble them and weld the whole thing together. The first thing that came to my mind when thinking about aluminium was, how heavy is the boat gonna be? The answer is 230 kilograms, which is about 1.5 times heavier than if we would have built it from wood. I have said in a previous video that I wanted the boat to be below 150 kilograms, but after discussing it with Dad, we have decided that 230 kilograms is acceptable because the dinghies will be able to lift it out of the water, as well as the winch to put the boat on the main deck. So we picked up the parts at Holland Steel, who did a fabulous job at laser cutting the smaller parts and plasma cutting the bigger parts. Back on the yard, we straight away started assembly, starting with the backbone and ribs, or keel and the frames. After which we could move it inside to the welding machine. Another downside from aluminium is that it shrinks during welding. So we have to weld it very carefully to avoid the material becoming all wobbly, especially with the thin 3mm sheets that we are using for hull plating. Next step is to get some rigidness in the boat. The quickest way to do that is the floor of the cockpit, as it automatically straightens the keel and prevents the frames from moving. Before you say our shed is too small, it isn't really. We just have too much stuff and really need to clean up sometime soon. Luckily, we can use a lot of old stuff that we have laying around for the new dinghy. We start with building the complete cockpit before adding the hull plating. I don't know if that's the most logical order, but in our case it made the most sense. The transom is the final part of the cockpit, and after some more welds it's time for the first flip. We place the boat upside down because that makes it way easier to install a hull plating, and we can straight away tack weld the floor of the cockpit to the frames. Working on the boat like this makes it look very big, even though it's only a foot longer than the old dinghy, which feels very small. But the new one is a lot wider and higher. While we're busy, here's some properties of the boat. It's 4 meters long and 2 meters wide. Weight without attachment is 230 kilograms. It's suitable for sailing, rowing and using an outboard engine. I had in mind that it should be able to carry 6 persons, but looking at it, the number is closer to 12, which is fine, but makes us wonder if we could have gone for a smaller dinghy. There are 2 watertight compartments, one being the floor and the seats, and the other one the little forecastle, so it won't sink even if the cockpit's completely filled with water. It will be able to land on any beach due to its shallow draft and sturdy build. Anyway, time to flip it right side up and install the upper hull plate and the gunwale. After closing the bow, the hull is completely tacked and only needs a lot of finer welds to make it watertight. I designed the transom quite high to make it seaworthy, but that caused another problem. A long-tail outboard motor is not long enough and only the bottom blade will have a clear flow of water towards it. This can be solved with a small modification to the transom. Before sending the boat to be laser cut out, of course I checked and rechecked everything for design faults. Still, some of them slipped through, like the floor of the cockpit being 3 mm too long, which was easily fixed by grinding it off. The only big fault that somehow slipped through is the forward bulkhead being about 1 inch too narrow, meaning the hull plating was separated from the bulkhead. We had to fill the gaps using extra plates in order to make it watertight, which did introduce quite some extra shrink in the material, which you will notice from the outside later on. Now we can install the foredeck and make it watertight. In all the stuff that we have laying around, there's lots of old masts, sails and rigging from old dinghies that haven't survived the test of time. So we decided to use all that stuff to create a new mast, boom, gaff, sails and rigging and clean up the shed in the process. This old rudder will do the trick, but since it comes from a boat with a much smaller transom, it needs some modification and structural reinforcements as well as a new rudder blade. You might have noticed we are not installing a dagger board. I'm not really a fan of dagger boards because they are a bit fragile and this boat is supposed to be able to land on any beach and sail well in shallow waters as well. Instead, we've chosen for a full-length keel with the same lateral area as a dagger board would have, making it about 2 inches high over the full length of the boat. This dinghy will not be a racing dinghy, so the sails don't have to be perfectly cut or anything. That means we can cut up some old sails and reuse them to create sails that will fit the boat. Maybe in the future we will have new ones made, but for now it's a great way to clean up the shed. All that remains now is a lot of hardware, like cleats, oars, rudder fittings, rowing bench and the mast foot. And while we were at it, I decided the boat needed a little jib boom. It's the extra things like this that made the project twice as long as planned. Anyway, some paint and it's ready for splash day. Overall, we are very happy. The boat is done. And by done, I mean we are still working on the sails, the davits need some reinforcement, and we will install some bilge keels to reduce the sideways drift. So it's done. Next time we will continue on the Tijgerhaai and install some solar panels. Thanks for watching.